So what were we doing in our previous lecture over here? हम लोग कर रहे थे bond dissociation energy और हमने बोला कि एक जो सबसे बड़ा application है bond dissociation energy का, that is to calculate delta H of a reaction. So we're going to do a few questions from this section now. According to bond dissociation energy, the delta HR that can be calculated as summation of bond energy of reactants minus summation of bond energy of products. Again, इसमें से बहुत ही simple जो questions है they come. So let's just discuss 5 or 6 questions from this section. First question जो है that is calculate delta H for the given reaction. So they have given us a reaction over here. ClCl and C plus 2H plus 2Cl. This is what they have given to us. Now remember over here that whenever we are talking of bond energies, the bond energy in the elemental state, that is always going to be equal to 0. It is but obvious because there is no bond formation which is taking place over here. So इसकी जो bond energy होगी 0 होगी, इसकी भी 0 होगी और इसकी भी 0 होगी, right? Now they have given us that the bond energy of CH bond, that is equal to how much? 415 kilojoules, 415, and that of CCl bond that is equal to 326 kilojoules. ठीक है? अब हमको क्या कैलकुलेट करना है? डेल्टा HR. So delta HR, this is a very simple question. Delta HR that is equal to summation of bond energy of reactants. So reactants हमारे पास 415 है. How many CH bonds are present? 1 and 2. There are 2 CH bonds present. तो हम 2 into 415 करेंगे because there are 2 CH bonds present and plus उसी तरह से CCl bonds present are also 2. So this is also going to become 2 into 326 minus that of products. तो products का इस पे क्या है? It is coming equal to 0. ठीक है? So simply you have to multiply and add over here. So we have 2 5s are 10. 830, ठीक है, plus 2 6 are 12, 5 and 656 minus 0, that comes equal to 6 8 14. So the answer to this question that will come to 1486. नहीं sorry 2, यहाँ पे 2 आएगा, 1482 kilojoules, right? So this is how, this is just a start, a very simple question. Let's start going to a little complicated ones. Second वाले question पे चलते हैं. So what is the second question over here? Second question हमको दिया है the bond dissociation energies of gaseous H2, Cl2 and HCl are 104. So H2 का कितना दिया हुआ है? Bond dissociation energy given to us that is equal to 104, right? That of Cl2 is given to us as 58 और फिर उसके बाद HCl का दिया है 103 किलो कैलोरीज पर मोल, 103 किलो कैलोरीज पर मोल, right? Now over here they are saying कि calculate the enthalpy of formation of HCl. So वापस reaction क्या आएगा? Half of H2 plus half of Cl2 that is equal to HCl, right? So bond energy क्या हो गई? Bond energy that is delta HR we have to calculate, that is equal to summation of bond energy of reactants minus summation of bond energy of products, right? So reactants की हमको पहले calculate करनी है, 104 और 58 दी हुई है. So this will become equal to 1/2 into 104, ठीक है, plus chlorine is given as 58, so 1/2 into 58 minus that of products. So products की हमको कितनी दी है? 103. So simply you will put over here minus 103. So what are we getting? This will come to 52 plus 29, ठीक है, minus 103. So this comes to 11. 81 minus 103. So that will come to 22 will be your answer. ठीक है? So it is minus 22 kilocalories per mole because minus 103 है, so minus 22 kilocalories per mole. So these are simple questions which come. Okay? Now let's go to another question over here. The next question, third question which we are going to discuss. Third question हमारे पास क्या है? Calculate the resonance energy of N2O from the following data. They have given us delta H F for N2O, which is equal to what? It is equal to 82 kilojoules per mole. So for this, we have to first calculate the calculated one over here. Observed heat of formation we will calculate. So observed heat of formation will be calculated by delta HR is equal to bond dissociation energy of reactants minus bond dissociation energy of products. Bond energy they have given for N triple bond N. The bond dissociation energy for N triple bond N that is equal to 946. ठीक है, 946 kilojoules per mole. That for N double bond O. N double bond N. N double bond N की उन्होंने कितनी दी है हमें? They have given it as 418. 418, right? Then they have given us the bond dissociation energy of O double bond O. O double bond O की bond dissociation energy that is given as 498. ठीक है? And finally they have given us the bond dissociation energy of N double bond O. N double bond O की कितनी दी है उन्होंने? 607 kilojoules per mole. 607 kilojoules per mole. ठीक है? Now over here when we are doing this, तो वो क्या बोल रहे हैं? Calculate the resonance energy of N2O from the following data. The question given, the equation given to us over here, that is, we are going to form N2O from N and O2, enthalpy of formation. So our was N triple bond N, ठीक है, plus half of O double bond O, that is going to give us N double bond O. This is going to be the structure. ठीक है? So let's calculate the delta H from the data which is given to us. N triple bond N की हमको एनर्जी दी है 946 plus half of O double bond O की हमें दी है 498. ठीक है? This is what we are going to get minus N double bond N की हमको कितनी दी है 418. So we have 418 plus N double bond O की हमको कितनी दी है 607. So let's calculate over here. इसको पहले कैंसिल करते हैं. This will be 249. So 946 plus 249, 9 and 6 that is 59 and 11. 1195. ठीक है? माइनस ये हमारे पास कितना आ जाएगा 8 and 7 is 15 and we have 1 and we have 10 1015. Okay, so इसको जब आप माइनस करोगे this will come equal to 0. 9 10 में 1 that is equal to ये ठीक किया 1195 आएगा कि 1185 तो नहीं आ रहा है. It's coming as 1195 minus 1025. Right? So 9 minus 2 that is going to be 70, so 170. Okay. Now when we have to calculate the resonance energy is observed heat of formation. Observed heat of formation minus कितना आया calculated heat minus calculated heat. Right? Now over here when we are taking the observed हमको कौन सा लेना है. So observed heat of formation is what is given to you in the question, 82, right? So that is going to be 82 और calculated जो आपने यहाँ पे calculate किया है that is going to be minus 170. तो आप इसको करोगे it will become equal to minus 88 kilojoules per mole. This is going to be the resonance energy. ठीक है? So these are the type of questions which are going to come to you, and there are many more which you can practice on your own, and if you have any doubt then you can come back to me. Okay? So these are the questions which are going to come. Let's go on to our next topic now over here, that is determination of lattice energy. Now what do we understand by, first of all, lattice energy? This topic we have also done when we were doing the covalent bonding, chapter 4 of class 11. So lattice energy basically क्या होती है? It is the amount of energy required to break 1 mole of crystal lattice. ठीक है? So if it is we are breaking a crystal lattice, in that case the value of lattice energy is going to be positive. But अगर we are trying to build up a crystal lattice, then the value of lattice energy is going to be negative. ठीक है? So मतलब कि it is the amount of energy released when 1 mole of cations combine with 1 mole of anions to give us 1 mole of a crystal. Then that is also lattice energy. In that case, the lattice energy is going to be released. And if we are breaking a bond or breaking a crystal, that is U is going to be positive. So इसको lattice energy को हम लोग generally U के साथ donate करते हैं, right? Now over here, lattice energy is not so easy to calculate by general formula, or you can say by general reactions. So इसके लिए it is calculated with the help of a cycle which is known as the Born-Haber cycle. ठीक है? क्या है ये Born-Haber cycle? In case of this Born-Haber cycle over here, let's calculate, or let's look at this by taking the example of NaCl. We know that this is going to be the reaction for the formation of sodium chloride. Right? Now solid cannot react in the solid form. So इसके लिए there is a cycle which is going to take us to NaCl over here. What are the steps to this cycle? In the first step, Na will take in heat in the form of sublimation energy, and it will get converted into Na gaseous. ठीक है? फिर ये जो Na gaseous है, that is going to lose 1 electron, and for that we need ionization energy to convert it into Na positive. ठीक है? उसी तरह से यहाँ पे इसको हमको atomic form में calculate करना है. So this is going to dissociate into its respective atoms by half of dissociation energy, and we are going to get Cl in the gaseous form. उसके बाद over here we are going to gain 1 electrons, and the energy which is going to be released, that is known as electron gain enthalpy, जो कि इसको convert करेगा Cl negative में. ठीक है? Now Na positive and this Cl negative, that is going to give us NaCl, and the lattice energy which is involved, that is going to be U. So we are looking at the energies over here, and we want to calculate delta HR from the data which is given to us. The delta HR according to Hess law should be sum total of all the energies, whether it is taking place in one step or it is taking place in more than one steps. So delta HR क्या आ जाएगा? That is going to be sublimation energy plus ionization energy plus half of dissociation energy plus electron gain enthalpy and plus lattice energy. ठीक है? Now in this case there are two factors which are going to have a negative value. The first one, that is electron gain enthalpy, will have a negative value, and second is lattice energy, that is also going to have a negative value. ठीक है, अब इससे अगर हमको U कैलकुलेट करना है तो U कैसे कैलकुलेट करेंगे? U will be equal to S plus ionization energy plus half of dissociation energy plus electron gain enthalpy and plus delta HR, right? Now in many of the books, instead of writing a positive sign over here, they've taken a negative sign here. Similarly, they've taken a negative sign there also. Because electron gain enthalpy is always negative. But I have taken a positive sign over here so that you do not get confused while doing the calculations. That is why? Because in this case, the value of electron gain enthalpy will be given to you in the question in a negative form already. तो कहीं आप ऐसे नहीं करो कि यहाँ पे माइनस है और इलेक्ट्रॉन गेन एंथैल्पी की वैल्यू भी आपने माइनस ले ली तो माइनस और माइनस प्लस हो जाएगा. Okay, so you need to take the value of electron gain enthalpy negative as it is given in the question. So that is why I have taken the sign positive over here, but in many books the sign is taken as negative. इलेक्ट्रॉन गेन एंथैल्पी भी नेगेटिव ले रखी होती है और लैटिस एनर्जी भी नेगेटिव ले रखी होती है. ठीक है, सो जनरली जब हम क्वेश्चंस करते हैं तो नेगेटिव और नेगेटिव को पॉजिटिव कर देते हैं, उसकी वजह से जो हमारे आंसर्स है दे आर गोइंग टू कम रॉन्ग. ठीक है, इज इट क्लियर? सो दिस इज व्हाट द साइकिल इज. नाउ देयर आर अ फ्यू क्वेश्चंस in this section also, but that we will come to later. Let's go on to another topic, experimental determination of heat of a reaction. Experimental determination of heat of reaction. Now, in order to experimentally determine the heat of reaction, we use an apparatus which is known as the calorimeter. Okay? We are going to use an apparatus which is known as the calorimeter, and there are two calorimeters which we generally use. One is the water calorimeter and the other one that is going to be bomb calorimeter. But before going on to both the apparatus, let's understand कि इसके behind principle क्या है, right? So principle जो है that is heat given out is equal to heat taken. This we already know. So what are we going to do over this is कि we are going to take two substances. That is, one is going to be the system and the other is going to be the surroundings. So हमने already thermodynamics में पढ़ा है कि अगर system heat इवॉल्व कर रहा है तो सराउंडिंग एब्जॉर्ब कर लेगा वाली हीट. ठीक है, और अगर सराउंडिंग हीट इवॉल्व कर रही है तो सिस्टम हीट एब्जॉर्ब कर लेगा. ठीक है, सो दैट इज द प्रिंसिपल व्हिच वी आर गोइंग टू यूज ओवर हियर, एंड मैथमेटिकली व्हेन वी आर गोइंग टू कैलकुलेट Q ओवर हियर, Q दैट इज इक्वल टू W plus M into S into T2 minus T1. So what are these all symbols signifying over here? Q over here will mean the heat. ठीक है, और जो W यहाँ पे हो जाएगा that is water equivalent of the calorimeter. This is set, this has a constant value. Water equivalent of the calorimeter. ठीक है, फिर उसके बाद what is S? S is equal to specific heat of water. ठीक है, it is a specific heat of water. Then T2 that is going to be the final temperature. T1 that is going to be the initial temperature, and M over here that is mass of the liquid in the calorimeter. ठीक है, now let's discuss the first type of calorimeter which we have, that is known as the water calorimeter. Water calorimeter. क्या होता है water calorimeter? It consists of an insulated tank over here. So we have So this is an insulation which we have done to the tank, and it is closed from the top, right? We are going to take two ridges over here. These may be pieces of thermocol, ठीक है? और इसके ऊपर we are going to place a beaker of water, a beaker which is containing water, ठीक है? So ये जो beaker है, water जो हमने लिया है, इसके अंदर we are going to place a thermometer in order to, you can say, monitor the temperature, ठीक है? और उसके अंदर हम लोग एक टेस्ट ट्यूब लेते हैं जिसपे हमने सैंपल डाला है. This is the test tube in which the sample जिसकी हमको heat जो है calculate करनी है, that is put in this. This is also known as the boiling tube. Okay? और फिर उसके बाद we are going to put a stirrer in order to finely stir the liquid. So this is going to be the boiling tube over here which we have taken, right? We have an insulated stirrer, and we have, these are below, as I just told you, the ridges which are present, they are known as they may be made of thermocol, they may also be made of cork. So we fill this beaker with water. Okay, now what is going to happen in this? How we are going to calculate the heat in this? Calorimeter में हम लोगों ने thermometer भी डाला है, हमने stirrer भी डाला है. Now the water which we are taking in this beaker should have a specific amount, a known amount of water that is taken in the beaker, ठीक है? And known amount of the reacting substances, they are going to be taken in the boiling tube. So what water we have taken over here, that has to be first measured. And when we are taking the sample over here inside this tube, that also we should know the mass initially. Okay? Now heat ball, that may be calculated as what? It may be calculated by the same method which is given over here. Q is equal to W, right? Plus M plus S T2 minus T1. Now basically what happens is कि ये जो boiling tube है, इसका temperature is going to be more. When it is placed in water, the water being cold, it is going to absorb the heat from this. उसको हम stir करते हैं to make the heat uniform over here, and henceforth by putting the formula W, which is equal to water equivalent, S is equal to specific heat of water, we already know, M mass of the liquid in the calorimeter, that also we already know, okay? And then finally T2 minus T1, that is the final temperature. We can record the temperatures over here initially before putting the boiling tube, और उसके बाद जब हम लोग इसको boiling tube को डालते हैं और stir करते हैं तो final temperature को record करते हैं और उसकी value लेके we can calculate the heat. Is it clear? So this is a very simple calculations which we do over here. The second type of calorimeter which we are going to have, that is the bomb calorimeter. Now what is going to be a bomb calorimeter? Bomb calorimeter generally हम लोग use करते हैं for calculating the heat of particular reactions in which it is much more insulated than the water calorimeter. ठीक है? So इसमें we are going to, again this apparatus is almost the same. We have a large beaker like this, or a tank you can call it, right? और इसको हम लोग properly seal कर लेते हैं. So this is how we are going to seal it, ठीक है? और फिर उसके बाद we are going to place a stirrer over here. This is going to be stirrer, and then we are keeping a steel bomb. Steel bomb means a vessel which is made up of steel, and that is also thermally insulated. Inside the steel bomb, the sample that is taken in a crucible, ठीक है? और इसमें हम लोग ignition wires place करते हैं. The ignition wires, they are used to melt the sample. ठीक है? Or we are going to continuously keep providing oxygen from one side. Why oxygen? So that ये जो यहाँ पे हमने ignition wire इसके अंदर डाली है, it needs certain amount of oxygen for burning. ठीक है? And on the other side we are going to place a thermometer. So this is how we are going to place the thermometer. और इसके अंदर हमने we have taken water. ठीक है? So this is what a bomb calorimeter is. It is going to consist of a sealed combustion chamber. This is the combustion chamber which is known as the bomb. A weight quantity of the substance in a dish along with oxygen under about 20 atmospheric pressure that is going to be taken in this bomb. So जो ये इसमें चाइना डिश में हम लोग या क्रूसिबल में हम लोग ले रहे हैं सैंपल, it has to be for the first weighed and then placed inside this. ठीक है? फिर उसके बाद and the pressure which is to be kept that is 20 atmosphere. Now in this we have put this ignition wire. Temperature of water is noted and the substance is ignited by an electric current. So initially before ignition over here we are going to take the temperature of water और उसके बाद हम इसको ignite करेंगे. ठीक है? जब ignite करेंगे तो what is going to happen? There is combustion of this going to take place, and when the combustion will take place, heat is going to be evolved. So that heat evolved will raise the temperature of water in which this is placed. ठीक है? क्योंकि वो water का temperature raise करेंगे, then the reading in the thermometer that is going to rise and we can note the temperature. ठीक है? Now what is going to be Q in this case? Or delta E, that will be equal to W plus M. It has the same meaning as we had already done. Then into T2 minus T1 into S, which is a specific heat, divided by W1. Now W1 over here, that is going to be the mass of the sample which we are taking in this. ठीक है? W1 into M. M that is going to be equal to the molecular mass of the substance which we have taken. ठीक है? So this is how you can calculate Q. W हमको पता है क्या है? That is the water equivalent. Yeah, equivalent of water. M is going to be equal to the mass of the water. T2 minus T1 temperature हो गए. S specific heat हो गया. W1 is the mass of the substance which we have taken in the crucible. And then finally we come to molar mass. ठीक है? So let's try and see if there are any questions of this sort from here. We'll just discuss one or two questions and then we go forward to our next topic. Our question is 0.5 grams of benzoic acid was subjected to combustion in a bomb calorimeter at 15 degrees centigrade. When the temperature of the calorimeter system, including water, was found to rise by 0.55 degrees centigrade. Calculate the heat of combustion of benzoic acid at constant volume and at constant pressure. So we have to calculate delta E and delta H both. The thermal capacity of the calorimeter that is given including water was 23.85, right? So we have to now calculate, first we will calculate delta E, that is the energy change at constant volume. That will be given as what? Heat capacity of the calorimeter. Heat capacity of the calorimeter plus its contents, whatever is present in the calorimeter, that we have to take over here, into rise in temperature into molar mass upon mass of the compound. So this was our formula we had just discussed. Molar mass upon mass of the compound. Okay. Now in the question, the thermal capacity of the calorimeter including water, that is given to us. So this total W into M, which we had just studied, W into M is given to us over here. That is equal to 23.85. They have given to us in the question that the rise in temperature is 0.55 degrees centigrade. So it is directly given. T2, T1 is not required over here. It's directly given to us as 0.55. ठीक है? Now mass of benzoic acid, you have to molar mass of benzoic acid we need to calculate. Benzoic acid that is equal to C6H5COOH. ठीक है? इसका जो molar mass आएगा that is calculated as 122. Okay? And then 0.5 grams is given to us. So divided by 0.5. This we are going to get as delta E. So when we calculate this, this is coming to 3200.67. Clear? Now in order to calculate delta H, we know that delta H that is equal to delta U plus delta NGRT. अब यहाँ पे हम U की जगह E ले रहे हैं, right? So in order to calculate delta Ng over here, we have to first write the equation. So equation क्या आ जाएगी? C6H5COOH solid, right? This is going to give us 7CO2 plus oxygen आएगा यहाँ पे in the form of gas, right? 7CO2 and we have 6 hydrogen over here. So 5 and 6, 3H2O. Let's balance the oxygens. इस साइड आपके पास 2 ऑक्सीजन है तो यहाँ पे 2 7s are 14, 14 and 3 17 oxygens are required. 2 are already there, so 15.2 oxygen. So this is our balanced equation. Over here, carbon dioxide that is going to come in the form of gas and water in the form of liquid. So what is going to be the value of delta Ng, products minus reactants? So there are 7 moles of products present and 15 by 2 moles of this thing present. So this is going to come as what? It is going to come as minus 14 minus 15, that is minus 1 by 2. So it will come as minus 0.5. Okay? So let's put the values. Delta H that will become equal to delta E is 3200.67. That is which is given to us is in kilojoules. So we have 3200.67 into delta plus delta Ng which is 0.5 into joules में R की value is 8.314. So you have to convert it into kilojoules. That will be equal to 8.314 into 10 raised to power minus 3, right? And the temperature given to us that is at room temperature 25 degree centigrade. नहीं, क्या दिया temperature होने हमें? 15 degree centigrade it's given. So 288 Kelvin. ठीक है? So when you're going to calculate this, this is coming to minus 3201 minus 3201.867 kilojoules per mole. ठीक है? Minus 3201.867 kilojoules. So this is how you were supposed to calculate questions from calorimeter. Okay? Now next we're just left with the very small topics over here. So I guess in the next class we are going to finish this chapter. So chapter 6 we will get off with. ठीक है?